Good day, everyone. My name is Samuel. Welcome to my YouTube channel. And today we're going to be talking about hypothesis testing. So, what is hypothesis testing? Is a way of testing the statement if it's true or not. Testing a statement using data if it's true or not. Now, let's take for example, you if you if you are working in the QC department and you have maybe the product coming to you, you used to weigh it. Maybe the first day you actually weigh it to be like 70 grams, 70 gram, and the other day the weight increased to 71. The other day too, the same thing, the weight it decreased to like 69. So if you want to check like, okay, these three figures that I'm getting, are there any difference between the three of them? That is when you come into using what we call the t-test or the z-test. So for the t-test, we have what we call the null hypothesis and alternative hypothesis. Same thing with the z-test. So I'm going to explain what is null hypothesis. Null hypothesis is just the idea of we not being biased. We just coming straight. Okay, yes, the average, like what we have here. Let's say we just say, okay, the average annual salary of women and men in Africa are equal. So in that case, we are not being biased. You just want to like, okay, yes, let's just say that we this is just what we just okay. We're just saying that they are equal. You understand? So no, you're not biased in that way. You don't know where it is going to, either from the left side or the positive side. Now your alternate hypothesis is the actual hypothesis you actually want to test. That is the statement you want to actually test. Now is the statement you want to test in the sense that you want to know if the average salary of women are lower than that of men in Africa countries. So for us to test this statement, we are going to use data to test it, and we have different parameters that we can use to test it. So today we're going to be talking about the t-test, and we're going to talk about the z-test. We're going to use it, and I'm going to show you how when to reject and when to refuse to reject. What I mean by when to reject, it means that if my critical value is lesser than or equal to the t-test, or they call it test statistics, definitely I would reject this statement. I would say this statement is not true. That is, it is false. Definitely my alternative hypothesis is what's it called, stand. That means my alternative hypothesis stand. So but if it's the other way around, whereby my critical value is now greater than the test statistics, definitely I will say I will fail to reject, meaning that I will say that this statement is stands. I wouldn't say true, because yeah, if I say true, nothing is true. But that means I just say fail to reject, means that you are saying that this statement stand, like, okay, yes, this statement is at some point you're saying is true. Let me use that word so that we can actually understand what I mean. So definitely, if this is true, then that means my alternate hypothesis um is false. That means it's not true. So let me just one more example again, then we go to the practical side of it. Now let's take for example, now if there's this belief that the gravity is 9.8 as a scientist. You understand? That's what we believe. That's what this has been the status quo from the beginning. So if a new a scientist come up to say that, okay, now I don't trust this 9.8, I think it is 10.7. You understand? Now my null hypothesis will be saying that the acceleration due to gravity is 9.8. That is my null hypothesis, because that is the status quo. That is what we know. You understand? So now my alternate hypothesis will now be that the acceleration due to gravity is 10.2, because this is a new this is a new hypothesis we actually want to test if it's true or not. You understand? So that's the difference between the null hypothesis, the alternate hypothesis. A recap of what I'm saying again: the null hypothesis is the statement you actually want to test, why the alternate hypothesis is the statement you actually want to test, why the null hypothesis is the status quo, what is actually B, what you're trying to not be biased, because in statistics you try to assume that nothing is everything is equal. That's what I'm trying to say. Now, in this our so let's go to the practical side of things. So this is what we call the sample size. So when do we use a t-test and when do we use a sample a z-test? When you're meant to use a t-test is when you have what we call when your sample size is less than 30 and when you don't know your population standard deviation. Okay, when you don't know your population standard deviation. Now, what I mean by population standard deviation? Now, if you want to know, as in this factor here, which is the average salary of women in Africa. So now, our population is the whole population in Africa. You understand? It is going to be very hard for me to take this data, get this data from every individual in Africa because of why? Because of number one is cost efficiency. For me, it's not cost efficiency because in the sense that it will cost us a lot to get that data. It will cost us a lot to get that data. Now the next thing is that we want to but we can actually use a t-test to actually test that statement, because the only way we can use a t-test to test the statement is that we are going to pick from the population, just pick randomly from different states or different country, then bring up those number and be able to like perform a t-test with that. So that's it. So number two criteria that can be met for you to use a t-test: number one, if your sample size is less than 30, and number two, if your population standard deviation is not known. That's when you use your t-test. And for z-test, if you want to use your z-test, number one thing that you need to know: your population, um, your sample size must be greater than 50, must be greater than 30, must be greater than 30, and your population standard deviation should be known. So let's continue. So now this is my sample size. I will need to check my sample size. So I will click on equals to. So now this is the hypothesis we want to test. We want to test the average salary of women are lower than that of men in Africa. Now, this is a one tail test. Reason why it's a one tail test, because we are saying it is lower, like we are checking in one direction. If we are saying that okay, there's a significant difference, definitely we are saying we are checking it. That is a two-way test. We don't know, is either it can be greater than or it can be lower than. If we say it is greater than, definitely it's still a one tail test. So in this our hypothesis testing, this is a one tail test. So let's continue, and I'll say count. So I'll go to my data here, select this, control shift and down, and close the brackets and hit enter. So this is my sample size 35. Well, yes, it's more than 30, but one more criteria: the thing is that we don't know our population standard deviation, because all these figures that we have here a is gotten from a population. Like the data is collected randomly. It is not a data that will come as going to all the household, going to all the place and all the whole place in Africa to get this data. So they will randomly select. So this is a test. This is a sample out of a population. That's why you're using a t-test. So we don't know our population standard deviation for this data. So that's why we're using a t-test. So the second one, we just come here and drag this. So both is 35, 35. Now we need to get our sample mean, and let's get our sample mean equals to average. Click here. So I would come back here, Ctrl Shift and down, close the brackets, hit enter. All right. So now we can actually see now from here that normally the average salary of women are actually lower than that of male. But come to think of it, what if you go to there's a tendency that way if you go to another state, as in 100, you can actually see that both of them might be collecting the same salary too as well. So does the way I attribute that to be like they are actually collecting the same salary? No. So that's why we need to actually, even though something looks true, it might not be truth. So that's why you need a t-test to actually test it that okay, yes, this statement is actually true, this figure is actually true. So now we go to the next one, which is the standard deviation. You say equals to st dev, and I'll come here, come over, copy here, Ctrl Shift and down, Shift 0, enter. So I would drag to this point. Good. So I want to get my mean difference. I will say equals to this minus this person here. Hit enter. So I have that. That's my main difference. So for me to get my t-score, there's something that we're going to do. We are going to use let me get my standard, my pool difference. Pool difference is equals to your sample size plus, I'll come back to that, plus, oh no, plus this here minus 2, hit enter. So that's my sample, that's my pool degree of freedom. So for this one, I'll tell us how to do it very soon. So now as I have what we call Data Analysis Toolpak. So for those of us that don't have it, I have my own here, but I will teach us how to bring that out. Okay, it's not here, so I would just go to the file, go to more, go to options. All right, go to add-ins, and that's where it's come up. Now go to, just click on go. So now I'll check this. I need this analysis Toolpak, and I'll click on OK. So now under this my data, you can see this data analysis have pop up. So I'll click here, click here. So this was going to help us do audio calculation. You don't need to start doing audio necessary calculation. This was going to help us. So I'll go to the tools, t-test paired, no paired. I'll go to the tools sample, assuming equals variance. Yeah, this is what I'm going to choose, because when you're doing your t-test, you're going to assume that they have equal variance. That is confirmed to almost scarcity. And I'll click on OK. Now it's asking for my variable one. My variable one is the data set from the woman, and the variable 2 from the male. So let's do that. I'll click here, then I'll go to this person here, select this, Ctrl Shift and down, and I'll hit this here, Ctrl Shift and down, click here. So back to my main difference, I'll need to go just type this in 199 8.38. Now this is my main difference. This is my main difference. That's what I get. So I'll just check this, and let me see. Let me explain this. Now, as what I believe that we should have a background knowledge on what we actually a background knowledge on hypothesis, because there's something they call the confidence level and the significant level. So my confidence level is 95 and my significant level is 0.05. So what am I trying to say is that, as I'm saying that at 95%, I'm saying that the null hypothesis is the statement is found to be true. Yeah, let me put it that way. It's found to be true. So as I'm saying that I'm confident that at 95%, 95%, I'm saying that the null hypothesis is true. You understand? So the higher your confidence level, the more the more accurate your test will be. So when you're testing something that has to do with medical, has to do with life or medicine or so, you have most of all those people, they make their confidence level to be 9.99 or something like very close to 100. You understand? So in our own case, 95 is still okay, still standard. At least it's, at some point we are just testing a statement that has to do with salary and non-medical field. So at 95% is cool, is okay. Now we want to make our output rate should be, yeah, okay. I think I have issues somewhere. Don't know if this is, think I, okay, let me do this again. So for the, let me choose this and Control Shift and down. Let me choose this again. All right, so now we would click here, my output range. Let me go back to test and why am I getting this? Oh no, I think I'm having issues. All right, Control Shift and down, enter. Yeah, okay, okay. Let me put on output range. All right, good. So I would click here. So let me select where I want my stuff to show. I'll choose that. Click here. So this one is click choose here and say okay, my output range. This is where I want my outputs to show. Then I'll click on OK. So now there we go. So this is my T score. This is my critical value for one tail. This is my critical value for two tails. So what we did one tail. That's what we got. That's we're going to use this value. So for the what's it called? The two tail. This is it. But we are not checking for the difference if there is greater than or lesser than. So we're checking in one way. That's why we have wanted. That's why we're going to use this value here. So we are going to make use of this value and this value. Now this value that you have here, if we are trying to check for the p-value, we want to make use of p-value because we're not using p-value to test. So that's why we're not going to make use of this. So let's just focus on this value and this value. So now the thing is that this is my critical level. This is it here, and my t-test, this is it here. This is my t-test here. But you can see that you have a bar here, you have a bar. It means that the absolute value of what you have here. Now, let me extract this out. So my t-score will be equals to ABS tab. That is absolute value of this person here. Close the brackets. Now divided by 2. Reason why I'm dividing it by 2 is because of it comes out like that. What the system does is that it do the two values together, so we need to divide the sigma by the alpha by 2, so to get our actual t-score. So I'll divide it by 2, then I'll get this. So I get 1.84. Now my critical value, I'll just extract it from here, which is equals to, then I'll hit this and I'll hit enter. So I get this. So now let's check if we're going to reject or fail to reject. So when I mean by reject, if I reject, then my null hypothesis, definitely my alternate hypothesis is true. Or let me just say, I really don't want to use the word true because nothing is true, but let me just say that means the alternate hypothesis is is fact. Let me put it that way. That means it's as is what we are going to stand on. Definitely the alternate hypothesis is true. Yeah, let me put it that way. True, fine. But let's do something. Let's say if equals to if. Now my logical test is, which is a critical value. So where's my critical value? Is this person here is lesser than or equals to this value here, comma, what should we do? You say reject. That means you are rejecting the null hypothesis. That means the null hypothesis is false, comma. So definitely the alternate hypothesis is true. But don't, I'm just doing it so that I'm just saying true so that we can actually get what I'm trying to say. You understand? When you're writing your report, you don't say it is true. There's a way you can actually say that as a 95% confident level, we can say that we reject the null hypothesis. Therefore, the alternate hypothesis actually which is the average salary of women are lower than that of men in African countries. That's all. So that's it. So let me just do this. Fail to reject. Fail to reject. Then hit enter. So now we reject. Then we definitely have reject this null hypothesis, the null hypothesis, and this one is true. This one stands. Then our alternate hypothesis stands. That means this hypothesis is actually correct. Now let's move on to the Z test. Z test, we say that in Z test, in Z test, what is actually needed in Z test that we need to have our population and standard deviation, and number two, we need to have what we call the population standard deviation, and the second one has to be like the sample size has to be more than 30. So now we have this data set we want to work on is we want to check the if the salary, these are our alternate hypothesis, these are hypotheses we want to test. We want to test that the average salary of employee that has left the organization is less than the average salary of employee in the organization, meaning that the people that have left the average salary of people that have left the organization is lesser than the people or the average salary of people still in the organization. We want to know if there is a age what's it called, if there is a salary difference between them. And the same thing, but then our null hypothesis will be the average salary of employee that has left the organization is equals to the average salary of employee in the organization. So what am I trying to say? This in this null hypothesis, I'm saying that they are equal. You understand? They are equal. This is I'm not trying to be biased, so I'm very confident they are equal by 95%. So let's proceed. Now, how do we know if we are to reject or to fail to reject? So if we want to reject, that's we are rejecting the null hypothesis. Then we say if, let me just come here and copy this because it's the same stuff that we're going to use here. Let me Control C here and come up here. Oh, I don't know. Control V, not working. Control V. Okay. And because if critical value is less than equals to um, Z score, what should we do? We would say we fail to reject. Let's say fail. No, we reject. We're going to reject null hypothesis. So that's all. So we're going to reject null hypothesis. But if it's the other way around, we're going to fail to reject. Else we fail to reject. So let's continue. These are the parameters we need: the attrition salary mean, the retention salary mean. That means attrition means people employees that have left the organization. Retention means employees that are still in the organization. We're going to subtract their mean and we get their variance and the both of their variance. So let's go to, this is my clean data. Let me go to my clean data, and I need to do something. All right. Okay. Yeah. Let me insert. All right. Click on OK. All right. Let me just put this. Let me see if I. Okay. Good. So I'll bring this here. I want to get salary of people that have left the organization. So I'll bring in my attrition to the filter. Then I'll take salary to the values. Good. Then I'll just people that have left the organization. Check this. People have left. This is attrition. So let me rename this to attrition number. Is it attrition salary? Okay, enter. So good. Um, so one more thing. I'll just go to design and let me just remove this as well. So now the next one is I want to get people that are still in the organization. So I'll create a new pivot table for that. Okay, I'll bring this to the row and then salary. And look what is salary, bring this here, bring this field, changes to check this, uncheck this, and I'll click on OK. Now this is our this has to be okay. That is retention salary enter. So let me change this to no. Retention salary is no. People that have not left the organization. See, check this and click on OK. Now good. Now this is what we're going to be working on. So we want to get the attrition salary mean. So we say equals to average attrition salary, then I'll select this, Ctrl Shift and down, close my bracket, hit enter. Okay, good. This other one, the retention, let me do something. I've not designed, I've not removed. Let me go to my grand total and then remove this. Okay, good. So let me continue. So equals to average tab. I'll go to my retention salary, select this, Ctrl Shift down, close the bracket, enter. So these are my two mean. Then I'll say my size difference. I'll choose this minus this, is enter. Now my variance. We all know that the square root of standard deviation is our variance. So let's do this. Standard deviation stdev. So we're going to go to the attrition salary. I'll click here, Ctrl Shift and down, close my brackets, enter, equals to, now stdev, tab. Okay, I'll go to the retention salary. I'll click here, Ctrl Shift and down, then I'll close my brackets, Shift and 0 to close brackets, enter. Now good. You can see at every point in time I'm closing my brackets. Look at it. Just that you can see I'm closing my brackets with Shift and 0. Now let's now use this value to get our z test, z score. So I'm going to come down here, z test to sample mean, then I'll click on OK. Reason why we're doing this is that we're using z score is that our population size is the total employee in the organization. You understand? That's our population size. So we have that figure. That's why we use the z test. If we don't have the total number, the data for all the employee in the organization, we are going to make use of a t-test. Yes. Now let's look for the variable one. Our variable one to be attributed to attrition salary mean. Now select this. I'll go to attrition salary, Ctrl Shift down. I'll click on enter. So my variable 2, retention, select this, Ctrl Shift down, enter. Now click out here and back to my Z score. Oh no, this thing has changed. Let's come here and do this thing again once more. So attrition, retention, salary. I think the next one is retention salary. Control Shift and down, enter. So double click here. Just click inside here. So just click inside here. So our potential mean this is this. I'll just press 1548.43423. Now our variance. Alright, I would do something. I've not calculated my variance. My variance, after getting your standard deviation, you need to square it by 2. So I don't know if the system will allow me do that, but I just need to fix that ASAP. So I'll cancel this and just fix that ASAP. So let me get my variance. Let me equals to this, shift and 6, 2, enter, equals to this, shift and 6, 2, and enter. So there we go. Back to this my stuff. Click on OK. So now my variable 1, I'll select this. I want to go to salary, attrition salary. Start from the beginning, Control Shift and down, enter. This person too. Go to retention salary, Control Shift and down, enter. So I'll click inside here. Alright, so let's proceed. And 1548.43. This is my main difference. 43423. Good. So my variable, which is this person here, I'll type this, which is my variance. This is my variable 1 variance. It's going to be 3918837.31. Now the second variance is 1689937.641. Good. So I'll check this. So we'll leave this as 0.05. Leave it at that. So we check this. I will press this. So output range. Where do you want the stuff to show? We choose here. Then we'll hit enter. Then we'll click on OK. Now there we go. So like we did the last time, let's come here and then put in our Z score. This is Z score. So what's our Z score? Our Z score is equals to ABS tab. So we'll select this, close the brackets, divided by 2, then hit enter. So what's our critical value? This is our critical value. Critical so critical value is because this is a wanted test, because we are checking if it's lesser than. So So this is it. So from here, if you say that if the critical value is lesser than or equals to the z score, what we do, we are going to reject. So definitely we are rejecting the null hypothesis. Definitely this alternative hypothesis is well, let me just say true. Yes, it is that means definitely is a fact. It has become a fact statistically that the average salary of the employee that has less that have left the organization is lesser than the average salary of employee in the organization. So now it has become a fact because we have rejected this null hypothesis because of our critical value is lesser than the z score. So that's it. So thank you very much, and I hope this is very educative. This is how you can actually use you can actually carry out your t tests and your z tests using data analysis toolpak in your Excel software. And then please don't forget to subscribe and don't forget to like my videos. If there's any video you want me to record for you, yeah, you can actually hit me up in the comment section and drop your comments. Thank you very much one more time, and God bless you.